View models. We've learned how to initialize them and bring them into our activities and fragments with the byViewModels extension function, this useful bit of syntax here. We have a problem though. We understand that our view models are going to need to do some of the database operations, things with the task DAO and the database. If I just undo to put the database back in. However, if I copy this and try to put it inside the view model, as we saw in the last tutorial, well, require context doesn't work inside a view model. I'll just remove that. And we can't say this for context because view model isn't a context. So at the moment, we're having a bit of difficulty actually giving the view models the database, the task DAO. Later on, we will look at a more sophisticated technique about giving things the dependencies they need called dependency injection. However, until we do that, it's time to learn about a very useful global space that we can use when making Android apps. We've seen activities, we've seen fragments. However, they can be created and destroyed as you move around the app. So I will just remove this for now. There is one class that is instantiated the very moment your app starts, even before the first activity is created, and this very special class will last for the entire duration that your app is running. Only when it is fully cleared off the background does this class ever get destroyed. And this class is called the application class. We haven't seen anything at all to do with an application class so far in this course. However, under the hood, we are using a default standard system one that is generated for us. Well, right now we're going to override this, extend it and make our own custom application class. And this will give us the ability to set up some global things, things that will be accessible from anywhere, things that will be kept alive for as long as our app is running, which is exactly what we want. Inside the main source set, opening up the Java folder, we have our data, UI and util packages. Well, you are free to put this special class wherever makes sense to you. What I tend to do is, when I'm making my projects or working in teams, we may have a tidy package structure like this, UI, data, util, some other things, and so I tend to just put the application class at the root level, outside of these packages, as the one and often the only class that is at the root level. So I'm going to right-click on the package and do New Class. Now we can call this whatever we want, but a good convention is to call it the name of your app, followed by the word application. So we will do exactly that. Get it done, application, all in uppercase. And we will extend the application class, Android.app application. And it's a class, not an interface, so we will do the curly brackets. And there we go. Now this has a life cycle of its own, but it's a bit more simple. This will last for as long as the app is running, and it has its own onCreate function. No parameters, no arguments, just like that. We must let the super.onCreate happen, so leave that in. Things will go horribly wrong if we don't have that. In fact, it won't even let you, that's how important it is. So we must leave that in. But underneath here, we can do some initial app setup, get some things that we want to be created and that should last for the entire life of the app. We can do that here. However, if I put a debug point here and run the app, let's see what happens. Okay folks, just a quick note to say that we haven't ran the app since adding the activity dependency. I'm currently targeting API 34 and version 1.10.0 only works in version 35. So if this happens for you, you can do one of two things. In the build file, if I close this down, you could target SDK 35, that could be okay. Or a simpler way to do it is to just use a lower version of these libraries. So let's do 1.9.0. We'll use the same version as the core KTX library and try and run that again. Okay, so I've done a Gradle sync, and I'll try again to run the app in debug mode. Okay, and that now is running. So I thought about editing that out and going back and changing where we first put this activity KTX version to be 1.10. However, I thought it's worthwhile to show you the sort of things you can run into when you add dependencies. Sometimes you may add a dependency of a particular library, like this activity KTX one, that is actually too high for some of your other config, like the target SDK version. Really, we probably should target SDK 35, as it's the most recent one at the point of this video. However, it doesn't really matter for the purpose of this tutorial and this project. But I thought it would be worth showing you the sort of things you can run into. The error did give us the information. It did tell us that by targeting, if you're not in time, and find it. I'll do that again. Debug mode. Nothing happened. And why is that? Well, the reason is we've extended the application class. We have get it done application. However, we haven't told our app, we haven't told the system to actually use this new custom application class. So where do we put that? And the answer is inside our manifest. Double click to open the manifest, or you can shift into it. You see here we have the application tag, okay? So to use your own application rather than the default system one, you have to add a new property in here that tells the Android system what and where your custom application class is. And that property is simply name. And usually you'll find if you've extended an application class like we have, it will suggest the one we've done. So in our case, it is .getItDoneApplication, dot because it's at the root of our folder. If you had that in the UI folder, it would be .ui.getItDoneApplication, but we've put it at the root so we can autocomplete. And now, when I run the app in debug mode, well, the onCreate breakpoint gets hit. So this will happen even before main activity gets created. I'll just continue. And there we go. So we now have the ability to do some setup inside here. And typically you will do things like set up dependency injection, set up any singletons. Perhaps you'll enable crash reporting, so any of your crashes get sent somewhere. It's usually the system-wide config, the app-wide setup that you do in the application class. And as you get to more professional and production-grade applications, it's pretty much essential to override this class to do the various setup that you need to happen before the app properly starts. Okay? And so what we'll do here in the next tutorial is we'll quickly use our knowledge of companion objects and making singletons and constants to make a globally accessible version of our database and our task DAO that can be used by the view models. Now that we have our custom application class here, the getItDone application, and we've put it in the manifest here, so now it runs when our app starts. We can use this for one-time application setup. We can use this to make our singletons and global things. Cast your mind back a few tutorials to some of the Kotlin concepts on objects. Can you think how we can make a global constant or a global variable that we can access from anywhere without having to make a new class? A companion object is the answer. So we can make an object here and we can do a val, a variable. In fact, we'll do a lateInit variable for our database of type getItDoneDatabase. And we can also do a lateInit variable for our task DAO just there. So we're saying we'll initialize those later, and we'll do the initializing inside the onCreate method. So database can equal getItDoneDatabase.getDatabase, and we can see that needs some context. And the fantastic news is that, much like an activity, the application class is a context. We can simply do this, and that will work. And because we're assigning it to our lateInit database variable, we now have this global database variable that we can use anywhere that we are initializing one time in the onCreate function of our getItDone application. And likewise, our task DAO can equal the database.getTaskDAO. And now, with this simple code here, we can access these from anywhere. So let's head back to our tasks fragment. And let's now delete the task DAO from here. Now you can see when we do that, I don't actually get any error because what's happened is it has imported it from our getItDone application. But actually we want to go one step further, and we're going to want to move this code into the view model so that the fragments and applications don't have to be concerned with it. We'll leave that for now, and we'll instead head to the tasks view model, and we can, for easy access, make reference to the task DAO here. We can do task DAO equals getItDoneApplication.taskDAO. And so now we can use this inside the view model. And we'll go ahead and do the same thing inside main activity. So main activity, we will get rid of the task DAO from here for now. Okay, it's going to import the task DAO from the application. We'll fix that later. But if I head into the view model, we can do the same thing. Make a variable called task DAO equal to our application's task DAO. This is acting like a singleton, but this time it's a singleton we can access from anywhere without needing to give context, without needing to give the database to it, as the setup is done one time in the application class. So let's now do one thing. Let's have the main view model actually add the task. So task DAO dot create task, passing in that task. What am I forgetting? Let's go back to main activity. We need to do it in a thread. So later we will improve the code to not do threads like this, but for now let's do exactly that. We will do thread, lambda, put that inside to make sure we're doing it on a thread, otherwise it won't work. And now, going back to main activity, we can replace this thread with simply viewModel.createTask, and we can pass in this and this. And I think I will do Alt-Enter, Option-Enter, and add the names to those call arguments. Okay, so we no longer need to create the task inside here. And if you scroll up, we also no no longer need to have the database here. And so little by little, our code in main activity is getting simpler, a bit more straightforward. We don't need to make a database. We don't need to make a task DAO. We just bring in our main view model there and call a simple function, viewModel.createTask, and the view model will do the rest. Let's try and run this to make sure we can now create tasks still, but this time using our view model, rather than doing it all in the main activity. So we'll run the app. And we'll test it, but this time using our viewModel.createTask, and the view model will do the rest. Let's try and run this to make sure we can now create tasks still, but this time using our view model, rather than doing it all in the main activity. So we'll run the app. And we'll test it, we'll open the dialog. Our button is disabled, fantastic. And my new task made in the view model, and save. And it works. So congratulations, for the first time, we are using a view model. It's being suggested that we can make this private because we only use it inside here. So now the activity is completely oblivious to any task DAO or database. It doesn't need to know, it doesn't care. All it does is it calls viewModel.createTask, gives it the minimal things. It's not even concerned with making the task object. Really simple functions, and the view model is doing the business logic. It is doing the code that doesn't relate to the UI, but relates actually to how our app should work, making the task object, saving it in our task DAO. Okay? In the next tutorial, we'll look to do a similar thing in our tasks fragment, replace the calls to the task DAO in the fragment with calls to the view model, and in doing so, we'll likely encounter some new problems that we need to solve. Specifically, needing to switch threads like this. We may have some problems doing threading in the view model and then being able to know about it back in the fragment. And then we'll use that as a launchpad into some new concepts and some better ways to approach threading. So, in the next tutorial, we'll start to look at the tasks view model. And that's our main activity and main view model working well. We've been able to simplify the code in main activity by moving some of the logic to the main view model. So now tasks are saved to the task DAO there and not in the activity. So let's try and do a similar thing in the tasks fragment. I'll just close the emulator for 1 second. So we have fetch all tasks, on task updated, and on task deleted. Well, I can go ahead and cut the thread from on task updated and paste that in, so update task. I'll remove the fetch all tasks for now from here. So here we will just update the task. You can see here we're requesting the get it done application task DAO. However, we have access to it here. So it is the same object in memory. It's the same singleton, but it'll be cleaner to just keep referring to this task DAO there. So we'll make that private. And I think actually rather than cutting and pasting that code, I'll just do thread and do the task DAO.delete task. So that's all very straightforward. Let's head back to task fragment. So now we can delete on task updated and on task deleted, or rather we can remove the thread and just do viewModel.update task with a task. And again, viewModel.delete task with a task. Hopefully you see again how we're starting to tidy up our fragment, remove the threading, simplify things a little bit. But how about fetch all tasks? What do? Well, we make a new thread and then we get all tasks. That's the first thing that we do. But then you can't update the UI from a thread. We have to get back onto the main thread, the UI thread. So we wait for the tasks to come back. And then once they've come back, we switch to the UI thread. And then we give the adapter our tasks. And this is where the way that we're using threads right now gets a bit problematic. This is not ideal. This isn't going to move to the view model quite so simply. I'll try and do the first part of this. So we'll go into fetch tasks and we'll do thread. And we will do taskDAO.getAllTasks. But how do we return this? Return there doesn't really work as you'd expect. We know that we need to return a list of tasks, but how do we do it? We can't return there. Can we return the thread? Well, no, that doesn't work either because that's going to return actually a thread object, not the list of tasks. So threading and returning things doesn't work quite the way you'd expect. So how can we do this? How can we give the caller of this function the list of tasks? And the answer is there's no easy way until we start to learn some new tricks in Kotlin. So one way that we could do it is offer a callback function. We could offer some code in here that we can call back, a bit like with our click listeners. So we can do callback, and we can now actually write a function that will accept a list of tasks. And the way you do that is with the curly brackets and the type list of task. And then outside these brackets, an arrow returning unit. Now we've not really covered function parameters yet, and I will likely do a tutorial on this in one of our future Kotlin workshops. I don't want to go into too much detail on it now because we're very soon going to use something much better than this pattern, this callback pattern. But rather than a variable of type string or of type boolean or whatever, you can actually do a variable of type a function. It's the same as this, my callback with a parameter of list of tasks, yeah, that returns, well, nothing. Remember, things return unit by default, okay? So that's kind of the same thing, but in very short format. And this probably looks very confusing to you. Don't get bogged down by this. This is a way we can offer a callback, but we're not going to have this as the complete solution. So just type this for now, this callback function. So what we can then do is once we get our tasks, I'll do this, our tasks, we can then give that to the callback function that we call with brackets. All very strange syntax, I know. It's not ideal that I'm just breezing through this new function parameter concept, but it's necessary because there's no other way to give our user interface the list of tasks back at the moment until we learn some new Kotlin tricks. So back in the task fragment now, instead of the thread, we can do this, viewModel.fetchTasks. And you see when I type fetch tasks, it offers us a lambda. And look, it is the list of tasks. Probably looks very strange to you this, but all we've done there is we've made it a callback function. We will eventually get the list of tasks back here. And we can try and just set the adapter with those tasks directly. So we'll try and just do that. I'll name the argument. So let's try and run this now, see if it works. Okay, and we actually got a crash. If I go to logcat, it says something we've seen before. Called from the wrong thread exception. Only the original thread that created the view can touch its views. So unfortunately, if I just close the logcat, because we're in this thread here, when we call the callback, when we invoke this and we go back to the fragment, we're still in this thread, which is not the UI thread. So unfortunately, it doesn't make for very pretty code. Acquire activity dot run on UI thread, and there we can then set the adapter tasks. So if we run this now, then we have no problem. And then finally, we are fully using the view model. We're not calling the task now directly. So we have viewModel.update task, viewModel.delete task. That seems to be okay. But viewModel.fetch tasks and things start to get a bit ugly. A callback, and then still having to switch thread. So a callback within a callback. And you see how it starts to get quite messy, quite ugly, and quite confusing to read, as well as to type and to remember. So we won't be using this. Don't worry about this new syntax. I will look at doing a tutorial on function parameters, which is what this is later on. This is a new concept. This is not the focus. The point is, kicking off threads like this is actually no good. It's not the best way to do this. And the good news for us in Kotlin is of the many, many benefits of Kotlin, one of those is a better approach to threading. Rather than making all these new threads and having to switch threads and things like that, and things with callback functions like this, we can use a thing called coroutines and suspend functions. This is a better way to manage threads in Kotlin. And so in the next few tutorials, we'll learn about coroutines, we'll learn about suspend functions, and we will change all of these threads to use Kotlin's suspend functions and then coroutines. And you will hopefully see how it vastly, vastly improves the way our code looks and also improves the way it performs. So let's now dive into a few tutorials on Kotlin coroutines and suspend functions.